Perfect. Good morning. Thank you so much for joining. This is Swami. I'm recording the session. So let me quickly share my screen so we can start discussing today's lab. So these are the official labs from Microsoft. So if you go and see this one, all these labs, whatever we are doing as part of the series are the Microsoft's official labs, and very frequently they update because we know the cloud and other environments are getting updated every now and then. Very frequently things are getting updated. So the Microsoft also does a good job to update it as and when someone mentions that there is a change between these instructions and the UI. So this is the fourth lab which we are doing, and we'll follow the instructions and we'll do it everything from scratch. So nothing is pre-created. This is the live session. If something doesn't work because of my mistake. Okay. So Ubaid, I need one help from you. If someone joins, please admit them. I'll be focusing on the demo. Okay. Thank you. Sure. So let's start with this lab scenario. So the first thing is assuming that if someone is taking training, in-person classroom training, so they will be given, or online also, they will be given a virtual machine where they load all the tools and you can log in into that. But we are directly using this lab scenarios. So in this lab, what we will do is we'll create a Azure Cosmos DB storage resource, and then using C#, we will access the Cosmos resource, upload the data, and then we will be going through an interface and displaying it. So you can see that web app is there. So we have the storage account, and we have the Cosmos DB. So this is the resource group. This box, the resources are in Azure, and this is our local. Okay, so let's go step by step. First, let's create what is this lab? AZ-204 Lab-04. Okay, let's create the resource group with the same name. I'll come here. Let me create, or else I'll create generic so that we can use it. RGAZ 204 labs. I'll prefix it. I mean, even though it is there, labs is there, but I just prefixed it 001. So that might create a problem. So if it is available, let's go grab that. Next, tags I don't want to create. Now the validation is passed. I am creating that resource group. Now the resource group is created. Let me go to that. This is the resource group. And okay. So the first thing instruction is they are asking us to log into that Azure portal. Okay, we are till there. Let me open a notepad and keep it aside so that it will help us to store some of the things which we might need it in the next steps. So in the Azure portal, first thing what we need to do is we need to create a Cosmos Azure Cosmos DB. So there are multiple ways to do this. So one of the way is through this, or I can paste this Azure Cosmos DB here. It goes and locates. We can go from there. There are multiple ways. Okay, we'll use this method. We'll search for the Azure Cosmos DB. It is here. Okay, So on the Azure Cosmos, select plus create. So here we can do it here, or you can click it and do it the plus create from there. So let's do it here. It is very quick. Then select an API option. So we need to select Azure Cosmos for NoSQL. So Azure Cosmos DB for NoSQL. Let's do a create. Let's click on that create button. So then subscription and the resource group we already created. And then the account name. Account name, let's see, we use Cosmos hyphen. Better to use all lowercase. You saw that that is the best practice to have everything in lowercase. So we just created that. And next option is let's use East-US. I mean, generally, I take all my resources, even though I stay in India, but I create all these resources in East-US. And that's the second option. And capacity, we have to leave it as the serverless. Capacity, we will leave it as the serverless. And then we have taken the account name. What is that? Oh, it's not resource group. Okay. Cosmos polyglot data. That's what we will take it. And then next we'll go to the next option where availability zones, we at this point of time we don't need it, but there are a couple of things which I would like to highlight. Couple of things I would like to highlight a little later. Then backup policy, we don't need it. But anyways, I'm going to delete this after this demo. So whatever I'll be charged only for that 1 to 2 hours, whatever we are doing it. Okay, we just created this one. Okay, so now while this account is being created, let's discuss something something else which I thought of to start. Okay, this is my GitHub profile. Generally, I do all the sessions. I'll have the documentation here because these are the live labs. I didn't create any of the documentation because we are referring the live documentation. And this is my meetup group where I create all the invites, and .NET Learners House Hyderabad. That's my YouTube channel for my meetup group, and all the videos will be uploaded here. Please subscribe so that anytime I upload a new video, you'll get notified. And all these sessions are happening from the Microsoft Learn community. If you can see this, each of the member in this Microsoft Learning rooms, we have been provisioned a separate tenant. We can see, and all these we will have separate learning rooms. People can join us, and they can join all these invites, and also we can have a discussions here. So anytime someone asks a question, based on my time, I will reply, but there will be 2 to 4 live sessions. Okay, that's about the marketing stunt. Let me come back to Azure Cosmos DB documentation. And there are a couple of things we need to focus here is the data modeling in Azure Cosmos DB. Just remember this one. So there are guidance. What kind of data should you store, and how should you model the data? When to embed the data? I mean, just that we are getting flexibility, that it doesn't have a fixed schema or rigid schema. Does it make more performant, or does it make problem to our life if the embedded data changes very frequently? The advantage is like we can read this document, person document, and how many times in a year address and this contact details change. Like I'm using my email ID since 25 years. So these email IDs will very rarely change. Phone numbers, assume that we might change every 2-3 years. I'm not sure, but let's take that way. And address couple of years. So having these kind of information embedded in the document or the object makes sense. Suppose if you are trying to store a data which is frequently changing, so don't embed these kind of things, because what happens is we might get an advantage when we are reading the content, but if it is frequently getting updated, like someone has added a comment and one more guy replied to it and one more guy replied to it, so the problem will be when you are modifying it. So there is a guidance here in this document, so where it gives us a pretty good guidance, like when to embed the data or when to normalize the data. So when you normalize, you might need to write a query to gather all this information. But the writes and updates, if it is frequently you're writing and updating it, it will be easy that it's a separate data here. Like you see that you have it in a separate object and only the reference will be stored here. I'm just giving you an example. So that way, if you see this, here you have all these things and comment. This is a post item and this is the comment items. So some way, if we refer this, like here, I'm saying that post ID is 1. So this post ID and these all are the comments. So that way what happens is it will be easy when you want to update the comments directly and add the comments. But still we are referring that these comments belong to that particular post. So we need to have a proper guidance. When should we choose the embedding and when we should choose the normalized data. Okay, that's the guidance. Let's go to the step 2, and then I'll come back and I'll give you some other guidance. So we just created NoSQL. And then once that is done, we need the URI primary key and primary connection string. Let's hold on it for a couple of minutes and we'll come back. So then we need to create a storage account. So in the storage account, again, we are going ahead with this one, but I would like to give you another URL, which I generally follow. Azure Resources naming convention. Okay, if I choose this Azure Resources naming convention, so out of this cloud adoption framework, you see that they give the strategy of how do you name it. So that's the same site we have come in. So you can see that Cosmos. So it should start with Cosmos hyphen. So we followed the same. If you see the resource group, also RG hyphen. So this is Cosmos. So it is Cosmos hyphen. So if I see for resource group, it should have a prefix. So that's how I use this document. So please use this. I really liked it. So I generally use this one. So storage, for all the storage account, we'll start with ST. So we'll follow this guidance, whatever was given in Azure documentation. So we need to create a storage account. Let's call it same polyglot data. We'll start with ST. Here there are some other rules. We will see that. So again, I told you we can use the recently created, or you can start with here. We can do multiple things. So let's come back here. The storage account is here. I selected the storage account. And here we'll start with ST, and it doesn't allow hyphens. I'll show you. Okay, nothing is allowed, only purely lowercase. So ST, that's the storage account. Let's use the standard and local redundant. And again, the redundancy will come into picture when you need the data to be stored and you want to recover. So those kind of things. Access tier is hot. That means it will save us the money in retrieval. That's a different thing. We will discuss about that. Let me create it and then go back and discuss a few other things which I wanted to highlight. Okay, now coming back to one is the modeling, and again, Azure Cosmos. Azure Cosmos, one was the modeling, and this one is the consistency levels in Azure Cosmos DB. This is very, very important topic from the exam perspective and from the real-time usage perspective. So these are the strong, bounded, staleness, session, consistence, eventual. So it depends upon, like if you see that consistency is strong and higher throughput, if you want, you can go ahead with the weaker consistency. And let's see, there is one nice graphics. If you see that each of this consistency level, strong consistency, that means if you write in one region, it ensures that the reads in all regions are having the same data. Now, what is bonded staleness consistency? You don't need to go through this documentation at all. You can directly come here. So bonded staleness, it says that writes are happening in a couple of regions, but reads, it's little late. The maximum delay is little bit delay. So by seeing this graphic itself, we can define that. So see session. So only for that session, you will have this reads. So similarly, you have consistent prefix consistency. So you can see that the order is happening, even though it is little bit delayed. So eventual consistency is, if not today, but some other day, you will definitely get it. I'm just exaggerating. It will be delayed, but eventually it gets updated. That's the jokes apart. The serious thing is that eventual consistency, at any cost, the things will get updated. Okay, so you can refer to this document. We can go through detailedly, or at least if you want to quickly analyze how it is, you can go through this visual diagram. I really like the idea. Whoever is the author of this page, they did a very excellent job and made our life easy to understand what is this consistency. Even if I'm telling my perspective, even if I read this this one page or 1.5 page, 5-6 times, I'll not be able to understand. But seeing this picture itself, it's pretty easy that I was able to understand very quickly. Okay, let's come back to our lab. Okay, even this resource has been created. So we are following the naming convention and we have both these things. So let's go to the next step we have created. Now review and upload the data. This is exercise 2. We completed exercise 1. Now we are doing exercise 2. In this exercise 2, we are working on the task 1. So task 1 is that we need to upload the images to the blob storage. Okay, so for that we need to create a container. We call that its name, and as images, and blob anonymous read access for blob. That means if I give you the URL, you'll be able to access it. So let's quickly go to this, go to that storage account. I'm opening these two different things in two different tabs so that it will be easy for us to navigate between these resources without delay. So let me come back to the storage browser. I can come in and create it from here also. I really like this storage browser. We can download the Azure Storage Explorer, but my choice is I use this portal itself. Okay. Private means no one will be able to access this because we need to use it from the website. Web application. So we are creating it. We create the images folder. We have created the images folder. We have selected the blob anonymous read access. Okay. And then we need to click on that select properties link. In the properties pane, we need to record the URL. That means if I come in here, back to the container, select the settings of the container blade. Okay, looks like this guy is asking us to navigate from here. I selected this and he's asking this. Okay, so this is the URL. Let's copy this URL and let's keep it over here. And the next instruction is on the blade, select upload. And here we have this files, select all 42 files. So we can do either way. My personal preference is this storage browser. I really love this interface. So I'll come in here. I click on upload and where are the files? That's a good point. So as I was mentioning, you can clone that Git URL. And then once you clone that Git URL, you will have access to all the files and all the labs you have it. And they will give you the starter as well as the completed solution. Both will be given. And here, if you see that, if you want to start from here, you can start and reach the end goal, or some of the things will be given in the starter from where you can start. Like images is one other thing which will help us to start with that. So let's take it, copy the URL, and I'll come and browse that. Let me select all the files, click on open, and click on override. So you can see that it's pretty quick. Some of the things it's uploading still. I think all the blobs, 42 blobs has been uploaded. Okay, looks like we are good in that particular step. So we have come in here and uploaded. We selected override if exists, and then we uploaded. And we waited till all the things got uploaded. Okay, so now review JSON data. So here in this Visual Studio, under the starter Adventure Works, there is an upload. We have the model JSON. So we can come back to that. And the same, we are dealing with Lab-04. So you can come in here under the upload. You have this model JSON. So you can see that each of this model JSON, we have the content, and this is embedding this resource. That means assuming that it will not frequently change. So, and again, I've given you that, shown you that document. Just go through for the consistency level and as for, and also the when to embed, when not to embed, either go with the denormalized data or the normalized data. It's a pretty good guidance. And the consistency level, most probably it will help us design a very good system. And from the exam perspective also, it is good information. So we saw that, I mean, it's a bunch of array, each representing a separate document or an object. Okay, now we need to create a database. And one important thing here in the one important thing I just wanted to speak about is the reference, how the reference about a particular object. So if you see that we have different type of APIs. So each API will have its own naming convention, like containers, someone will call as a database, document, like these kind of things, records, different things are there, but we need to understand that before going. If you see here, we are calling it as container and items. So at the same time, if I come in here in the MongoDB, this might call it as document, if I'm not wrong. So similarly, each will have its own way to identify or represent an object. Like if you see, this is like a table and record. Okay, table and Gremlin will have a different way to call it out, like what is that object. So some people will call it as a database and document or item. Different things are there, but just understand, but it all represents the same object in a different names. Each has got their own naming convention. So because we have used the SQL API, here we are calling it as database and then collection. And another important thing I wanted to highlight is the request units. Okay, so RUs, request units. So this is very important concepts. Okay, so when it comes to the provisioning, you can see that usage is expressed in request unit. So how much memory, CPU, and input-output operations you are doing, the combination of all these things is called request units. So to read 1K document is known as one request unit. So similarly, there's a big calculation. You can get deep into the weeds to find out how much you are getting charged. So here you can see this one, item size, like indexing, item property count, index properties. You need to get deep into this one to find out the request units. So our output will impact based on the request units. If you have less number of request units, but you're trying to do more operations, so there might be a contention, and our the performance of the solution which we are giving will be little slow. So the request units is very, very important. You need to consider that before choosing it. Now let's go and finish the task 3, where we are creating the Cosmos database and collection. So let's come back here, and File Explorer, we already here, and select the folder. In the new terminal, we need to get into that upload folder. Oh, okay. So he's asking us to come into this one, upload folder. I'm just going into the full-blown one. Okay, technically what is happening here, so this database name is creating and the container name is online, database name is retail. So those are getting created, and then we are uploading all the items from the JSON. So where is that? I think is giving as part of the instructions, because we don't have any. That's a CS proj. It's .NET 6. That's cool. And model.json, it is here in the program. I think we need to refer. No problem. Let's go ahead. So we need to select the new terminal. So the simplest way to do is right mouse click on that and open an integrated terminal. So it exactly, we don't need to do cd. It exactly comes and opens that terminal in that particular folder. I can do a DAR. It clearly shows that the CS project SLN, models JSON and program.cs. Okay, we are here. And okay, we'll see that. The add package, do we have this? We don't have that. So let's add this package. .NET add package. So that's adding the reference to this NuGet package. Let's give it a minute. It will update this CS proj. See that? It has updated the CS project. Cool then. So once that is done, in the Explorer pane, we need to go into this, and we need to review the usings. Okay, let's review the usings. We have a bunch of usings here. And then in the program.cs, we need to get the endpoint URI, and authorization key is primary key. And the partition key is this one. Okay. And then he's telling to on line 19 JSON follow replace the empty string with this. Okay, so let me get copy the path of that and come back here and let me paste it and add the @ symbol. Okay, so now we need to get the endpoint URL and authorization key. So where do we have this endpoint URL and authorization key? We can come back to this Cosmos, and we got the endpoint URL. Right. Then we need to get the authorization key. So let's go to the keys. And it's not the connection string. He's asking us the authorization key. Okay, so that is this one. Let me copy and come and paste it here. Oh. Now it is unblocking. Now I copied it. Right. So we have this. So we have the endpoint URL, we have the authorization key, partition, and line 19, we have the models JSON also. Okay, and he's explaining what is happening here. Define container method is here, and we are using the stream reader, and review the model and product classes. Okay, so let's see. Here is that model class, and here is a product class. So which should match this guy. So this is the model. Model is ID, name, category, and description. You can see that model is ID, name, category, description, photo, and collection of products. So similarly, the product information is here. Everything is here. All is well. So let's cross our fingers and build it and see that are we able to. But I'll do the restore if at all something is left out. So we are executing the .NET build. So the build is also success. We can see it has created the .NET upload. Here it is, the DLL and executable and PDB file. So that's it. Perfectly, it created it. And also just want to see that these are intermediary files, the OBJ folder. All is well. Everything is good. We were able to compile and we do .NET run. So technically, if you see what is happening here, we are creating the client in 29 and creating the database if it doesn't exist, and creating a container if not already exists. And it gives a lot of the consistency level and all best practice things are happening. Then it's opening the JSON file and it's deserializing, and then getting this container and looping through the each and every object inside the JSON and inserting. So I think I do need to run the .NET run, and then we'll come back here real quick to go to this data explorer inside this Cosmos resource which we created. Okay, and you can see that retail, and this is online. And here, if you see the specific naming convention, the naming convention is database, container, and items. Okay, so you can see that all the individual objects within the JSON has been uploaded successfully to the Cosmos DB with that few number of lines, preparing 119 items to insert, and it was able to insert 119 items in less than 5 seconds, 4-point change. And that's because my machine, a lot of things are running. If not, it would have been done in 2-3 seconds. Okay, so I think we are done with that also. Now validate the JSON which got uploaded. So Cosmos DB, we went into the data explorer, and we can do this way also. This is another way where we can use the queries to validate. So it's like a SQL like query. So you can come in here and execute the query, select star from models. So it's giving this all models here. Okay, and you can check this command also. I'll execute the selection. So you can see that 119 objects are there, which we were able to validate that. Okay, so the next thing is configure the web application. So they already created the AdventureWorks web application, and inside that app settings, we need to have the Cosmos context path. So with the primary connection string, one thing to observe here is in the C# program which we just used the endpoint and the authorization key. So here we are using the primary connection string. That is one difference we need to understand. So if again I need to come back here and the primary connection string. So see the primary connection string, like he's telling the account endpoint is this endpoint, and what is the account key, everything they are mixing it for us. Copied. Okay, that's cool. It's copied. So if I come in here, I need to go to the AdventureWorks web project. So I'm using solution directly. So here I will come in the app settings. I need to paste this here. Okay. And the next thing we need to do is we have this one, the URL. Now update the URL with the URL property of the storage account. So this is the storage account, container URL. So this container URL, I think we have copied previously. So let me go ahead and update the container URL. Okay. So we did two things. Primary connection string we added here, and blob container URL, we kept it here. Then update the blob container property by setting its value to URL property of the storage account storage blob container named images. So we exactly copied and what is there. Then Visual Studio window, we need to right click on that and explore and then select the same thing, whatever we did it in the previous exercise. Let me close this so that we get some extra space. I will close this and then rightmost click on that and open reveal in container. So we are back to this one, and then we will come and again open the CS proj just to ensure that whatever we are adding is getting affected here. So we have added a NuGet package. Ah, God, sorry. We added a NuGet package, and you can see that NuGet package has been updated here, the Cosmos. Okay, then we do the .NET build of this is coming in from the solution. Yes, we are exactly .NET restore. I mean, the restore would have definitely happened, but bad habits die hard. So got habituated to do a restore. So now we are building it. So it builds the projects which it is referring as well as the current project. So we are referring the context and models, two different projects which are here, the context and models and the current project. We built all these three, and we need to do configure the connectivity to the Azure Cosmos DB. So in the context node, select a new file, and we need to add this context, and we have to do these changes. I think the solution means I think they would have already baked it. Yes, they already baked this up. AdventureWorks Cosmos, it's already baked in. We don't need to do this step, because if you're coming in and doing everything from the starter, if you see, if I come into the starter inside this AdventureWorks, if I go to the context, we don't have anything. They just provided what is base minimum required, just given an interface. But what I'm doing is I'm using the solutions directly. They have written the entire code. They have the interface and they have implemented the interface in this one. So let's use this, make our life little easy. Okay, and once we save it, select the terminal prompt, set the current directory, and build it, which we already built it. Okay, Just to be on a safer side, I will go ahead and build this one also. Build. So the context, we can see what all the things this guy is referring. So this guy is referring the model project. So technically we need to see that the same two models which were there while we are uploading, that guy technically would have referenced this project so that there's no duplicate or dry principle, don't repeat. But anyways, there will be one good reason if they did it. Apart from that, first we need to build the models, and we see that model doesn't have any references. Then we need to build the context, because context has got reference to the models. You can see that models, and the web project. Let me kill these two terminals. So let me come back to the web project, and if we come and see the web project here, the web project is referencing model and context. So we build model, we build context, and we are building the web project. So which has got reference to other two DLLs. If you see that, model and then context, then web. So model doesn't have any other references. The context has reference to the model, and the web project has got reference to the model and the context. All these things were successfully built. So I think that itself is a 50% of the world piece. Now the task 3 is that we did that and start up and note the existing product service method. What is that which is happening? Oh, okay. So we are passing the we're adding this scoped instance and then passing the provider. So let's go and see that in the startup class. Yeah, here. So the product DB context, we are adding it as a scoped, and then new AdventureWorks Cosmos context is that this context is being injected to this one. AdventureWorks Cosmos context. So we're getting the connection string of this context from here. This one, get connection string. So that is being passed. And after that, we come in here and we will run this project. And do we have any specifics? That's a mountain, and we have a couple of pages. We have configuration. So we have the strongly typed object, which is getting this blob container URL. And there are a couple of pages. We have layout, view imports, view start. There's a detail and index page. Only 2 pages are there in this ASP.NET Core MVC project. And let's go and browse the HTTP version. So it's loading this HTTP version. Woo. So we were able to come here, and you can go and see all the images, whatever we have uploaded, we are able to see from here. So we have, at least I see 2. Oh, okay. 2 things. One is index. Index is the one which displays this UI. So we have the model index here. And this is the strongly typed configuration, and we are referring that, and we are traversing through model.models. So the model is a page model, and models is list of model. He could have used a separate name. Okay, it should be fine. So the list of model is coming in. So if you see the CSHTML, we are traversing the model.models, that is list of models, and we are displaying the front end. And while displaying the front end means the visual interface. Okay, so we have everything. Somewhere you should see a reference in line number 23. You see that ASP page is details and ASP route ID is the item ID. So that means if you go to the details page, on get async ID good. So that means from this line number 23 over here, you're saying that, hey, if I click on this link, go and hit this page and pass the item ID. So that means it will come and hit this method and it will populate the model object here, the one in line number 21. It retrieves the product DB context, find model async, and assigns this model. And once that model has been assigned, you see that at the rate page, that's a routing piece. And we are specifying the model is details, and we are getting the strongly typed configuration. And here we are going through that particular model at the rate model.model.name. You could have called it as a, oh, now I understood. This model is the model which we are referencing here. I got confused. This is the model. We could have given item or some other row item or something different name, so that we'll not be that confused. I was a little confused. So this model, whatever we are referencing, is the object which is coming in from the library AdventureWorks context.models. So that is coming in from there. So we are finding that, and then we are going and displaying it here. So if you come back to the browser in the view details, if you place the mouse on that, you can see at the bottom here, you see the hyperlink. When you click on that, so it takes to the details object, and you're able to see this one. So now that's how it's being composed, this web project. So we're able to successfully test this web project. Let's go back here, and yeah, we were able to do that. So that's the session for today. And from the exam perspective, it is very good exercise for you to understand three different things we are doing it here. One is creation of resource group and resources. Let's quickly recap what all the things which we did it. We created a resource group, and that resource group has got the Cosmos DB account and the storage account. And inside the Cosmos DB account, we didn't create anything. We left it as it is. And in the storage account, we created a container called images and uploaded all the images to this particular folder. And then later we came back to the upload console app. And inside the console app, we have the models JSON. And we have added reference to Microsoft Azure Cosmos. And then we were able to give all the details over here. And then it went and retrieved this JSON, created the database. You can see the names will be a little bit different based on the type of API we take. So we create the database, we create the container, and then we upload each and every object. We verified that, we verified the images. Then the next thing is we came to the web application, and we did few things. We updated the app settings with the connection string, and the line number 6 blob container URL, we are referring to the images. And here, two different things are there. One is inside the models, each individual object or item and product. There are two entities which is referring to our object in the Cosmos DB. If you come and see the Cosmos DB, inside this Cosmos DB, if I go to the retail and online, inside that items, each of this is the model. This represents the model. You see this ID name category. So this is representing the model. Okay, ID name, category, description, list of products, and photo. So list of products, if I minimize this photo, it is here 1, 2, 3, 4, 5, 6. 6 properties, 1, 2, 3, 4, 5, 6. So this entity refers to this. And the product, inside the entity, you have list of products. So each individual object inside that list, see, you have ID, name, number, category, you have color, size, weight, listed price, and the photograph of that. So that's the modeling of the database. So here we should again very carefully understand that the embedded object, if you see that these are the things which is getting embedded, assuming that you're not doing, there is very less inserts or very less updates. Okay, if there's a frequent updates to that. So this way of designing the modeling the database might have an performance issue, or there might be slowness. I'm not sure, but I'm telling because based on the this object, again, you need to go and check within the list which object we need to update. It's not a big thing, but just wanted to be a little safe. And in the context, you saw that there was an interface and we have a concrete class, and this concrete class has got a couple of methods, and you see that you're getting the connection string, the database name in the constructor, and then find async. This is the method we have seen in the detail, and get models async and find a product. Okay, these three methods are there. Those two libraries are being referenced here in this web project, and we have got 2 pages. One page is index. That's where we'll see this. Index is having the model.models. That means models is list of models here, and this model is coming in from here, this library. Okay, and inside this CSHTML, we are traversing in the for loop and displaying the visual interface for that particular row item. I'm calling it as row item instead of model. Okay, and here is the key piece in line number 23, where you're saying that they go to the ASP page details, and I'm passing you the ID of this current item. So that way, what happens is, if you see the detail here on async, you're getting GUID, and also at the top in the details page, you should see that ID, and we are specifying it is of specific type, GUID type, and that ID is received here. And once that is received, this model, and again, this model is this model over here is coming in from the model library. Okay, and that's how it displays. So this is Lab-04. We have successfully completed it, and let me stop the recording. Hope you guys have